Good.
Are we on?
You're on.
Right. So today we just sort of put together the previous two things. So name me a fact that we've been finding in the graphs in other days. Amplitude. Out of these letters, which one would lead you to the amplitude?
B.
Agree with that. B will tell you the amplitude. Name me another item we've encountered.
Period.
The period. Which letter leads you to the period? C can. Another thing.
Vertical displacement.
Vertical displacement is the A.
Wow. Okay.
Leaving us the D. That is called the phase displacement. Which one of those four involves math?
C.
C. How do we get the period?
360 divided by C.
360 divided by the C. Someday we have a vocab test a test for the chapter that involves some vocabulary. If I ask you on that, which I'm 99% sure I do, what the C tells you, the C tells you the number of cycles in 360 degrees. That'll be the next time you need that answer, if you even need it then, but I think you will need it then. A, B, and D directly tell you facts you want. C can directly tell you how many cycles there are in 360. The period measures only one cycle, so you have to figure out the period doing 360 divided by that number. For example, if I stroll over to the right, this 3 is telling you you have 3 cycles in 360 degrees. So what would they each be?
What's the question?
This 3 tells you there's 3 cycles in 360.
Yes.
So each cycle would take you 120. And the 120 is called the period. Correct. So that has a period of 120. This 2 tells you that there are
180s.
2
Cycles.
in
in
360. So that each of them is
180.
and 180 is called the
Period.
question about things there. Here's a new word that appears today. There's another thing called the frequency, which is linked to the period, both in trig at present and also in physics in our future. The frequency is just the reciprocal of the period. So if I take a stroll back to the right, the period is 120. So what would the frequency be? 1 over 120. This would have a frequency of 1 over 180. The frequency, I don't think I asked this question on the vocab, but in case I do, the frequency is the fraction of the graph, the fraction of the cycle you get in 1 degree. So if it takes 180 degrees to repeat, each single degree gives you 1/180th of a graph. That's all that's about. Question about ideas, the only one of which is new is the frequency idea.
Is that the only new thing we're doing today?
Yes and no.
Okay.
Depends on your point of view. So here, what was the 7 going to tell us?
The vertical displacement.
Vertical displacement. All my little chalk stubs are biting dust. So vertical displacement 7, what's the 4 about? Amplitude. Phase displacement is 10. Let's finish building this list. What was the negative 10? The 20?
Amplitude.
Amplitude. Phase displacement?
Negative 30.
Negative 30. Question about list gathering. So a minute ago when I was asked, was it just making the graph? That answer was no. We have to make a graph, but also list make.
Okay.
Think of our favorite 5 facts now. Question about list making skills. Does the vertical displacement affect your y-axis numbers on your graph or your x-axis numbers? They're going to affect your y-axis numbers. Does the amplitude affect your y-axis numbers or your x-axis numbers?
Why?
Y-axis numbers also. When we go to make our graph in a second, it matters which of those we put on first. What's the vertical displacement measure? How do we find it? What's it do?
Starts you higher.
Okay, it makes us start higher or lower.
Or
Where's the amplitude measured? What's that do for us?
The distance between your points.
Okay, so which of those seems like the one we should get established first?
The vertical displacement.
I would agree with vertical displacement. On the y-axis, you will have to graph the vertical displacement first. Before, second, you improve your y-axis by doing something with the amplitude. So vertical displacement 7, where are you headed?
offset.
Up 7. And I'm going to make a dotted line called the axis. Then with an amplitude of 4, what does that do for us?
Go down
We go down 4, so the lowest low
3.
is at 3. What else should we do with the amplitude of 4? Go up 4, so highest high
11.
is 11. And we're good with the y-axis from those. Would we have to do the y-axis first? No, we could do the x-axis first too. Which of these numbers would be my first number to throw onto the x-axis?
Phase displacement.
Phase displacement. In the x-axis direction, you have to do the phase displacement first before the period goes second. So what's a phase displacement at 10 do for us?
It takes you to the right.
Takes us to the right 10, and that's our starting position. How does the period of 120 affect us? So how will it appear on the graph?
Like at the end will be 130.
I agree. At the end will be 130. Where did 130 come from?
120 is 30.
Added on. Okay, so the phase displacement's your starting line. Add on the period so you can figure out your finish line. The most effective way to figure out what that middle mark should be is averaging those 10 and 130. Add them up. Divide by 2.
70.
It is 70.
How did we get the 130?
Added on the period to the starting line.
Okay.
So this is telling us it'll take 120 to repeat, starting at 10.
Okay.
So the repeat will happen at 130.
Thank you.
Well, I'd average 10 and 70 to get this line.
40.
It's 40. Average 70 and 130 to do this line
100.
is 100. Question about that? When you go to do this shape, you have to fight off the temptation that we did sort of iron in the first day of using the x and y axis. We're no longer on the x or y axis probably at all, ever. So you probably are not, small chance you could by luck, but almost no chance you're going to have any dots on this y-axis or on this x-axis. Where should we start a cosine graphing procedure?
11, 10.
At the 11, 10 line. So the starting line was 10, cosine always starts off high. When we get to the next mark,
40, 70.
be at the axis, at the next mark,
Down at 3.
low to 3, on the next mark,
Up to 7.
on the axis at 7, and we always finish
At
The 11.
where we started. And then you try not to draw a V. When you first see the dots, it always looks like a V, and you try to fight off that urge. That's number one, straight out of the homework page, free of charge. Homework preview. Something about one. Skipping to 3, this is the equation for 3. We're already halfway done with 3. Make ourselves a graph. Let's do the x-axis first this time, just for variety. No reason you can't do the x before you do the y. Where should my first x mark be?
To the left 30.
Left 30. Then what are we going to use?
The period.
Use the period of 180.
150.
150 is going to be our finish line. There's one, I think, on a sheet somewhere that I give you such a negative phase displacement that the entire thing is actually negative. Like, that could happen. You know, if I gave you a phase displacement of negative 300, like, the whole thing would have been to the left. Middle number here. Is 60. Middle number there.
Would be 45. 15.
15. Middle number there. $105. Something you could check as a check, make sure all the gaps are always the same. The gaps on these between every number was
30.
30. The gaps on these every time
45.
is 45. For the OCD people, I'll move the number I had on the top just to go down underneath because I wrote all the other ones down underneath. So. Consistency. On the y-axis, who's going first?
-10.
Negative 10. So I'm going to draw myself a dotted line and label that with negative 10. Highest high
10.
is positive 10. Lowest low, negative 30. Picture not quite drawn to scale because obviously that is not the same gap as that, but life goes on. I could move this down a little bit if it make you feel better, but it still would not be to scale because if that's 10, that's 10, that's pretty good, but that's not 20, but I'm out of board space, so sorry. Likelihood any of these dots is going to be on an axis, x or y axis.
Almost 0.
Almost 0. What you are going to touch is the dotted line axis that we created pretty often. Where are we going to start? This time it's a sine graph.
-30, -10.
Start at negative 30 on the dotted line. 15 line, we'd want to go
To the 10. And
to
then
the 10. This is a common wrong spot people would go, because you know it's going up. It's a common wrong thing to put the dot there. 10 is a line that matters to us. The x and y axes themselves have lost all meaning.
Back to our
60, we're back to our created axis. 105,
down to -30.
down to the basement, and at 150,
Back to axis.
our created axis. Voila. Question there? Is there anything new today? Dependent on your point of view was my answer. Find the homework page and look at number 9.
What page is it?
I'm working from 35, I just spilled into 36. So when you look at 36, is there something new today? Maybe. What's up with 36, number 9?
Same like repeats itself. It keeps going.
How is 1 to 8 dramatically different than 9 to stuff?
Oh, it's a picture.
They're what?
On 1 to 8, they give you numbers. On 9, they give you a picture.
Yeah, your goal on 1 to 8 is the same as what it was all the other days. They give you an equation, they want a graph. What they do on 9 is they give you the
Graph.
graph,
They want
and they want you to reverse the process. So is that new? Sort of.
Do they just want the list, or they want an equation?
We're going to work through the list to get to an equation.
Okay.
So basically, I think by now you've figured out everything in math that you can do forward, you can also do backward. Everything is a two-way street. Anything that can be done can be undone. Everything has an opposite. It's just the way math works most of the time. All the time, maybe. So for 9, what we're going to want to do is look at their picture and build ourselves our same list of items that have the same meaning as they have. Just try to spot them. Can anybody spot any of the numbers for 9?
Vertical displacement's 9.
Vertical displacement is 9. Where do you find the vertical displacement? That is usually one of the easiest ones to spot.
On the y-axis at your axis.
Yeah, we look for the dotted line, like man-made axis, and we need to figure out a number for that. They were a little unkind because they didn't label that number. If you look down at something like number 12. Number 12, they labeled that number, so they were kind. Ours on number 9, they didn't label that number, so how did Amelia figure that out? Somebody other than her, because she's the one that figured it out. Average. Average the 3 and the 15, add them up, divide by 2. The 9 would be the vertical displacement. While we're on that topic, why don't we keep looking at the y-axis? Which other number is on y-axis involvement?
Amplitude.
Amplitude. So if we know the middle is 9, how much would the amplitude be?
6.
6. Because either from that 9 up to the top or the 9 down to the bottom, 9 and 6 coming from the y-axis, question about those two. Let's plot those numbers into the equation. Where does the vertical displacement always go? At the very beginning before the plus. Where does the amplitude always go?
After the plus.
Right after the plus. So we're going to go 9 plus 6, and then we have some more stuff to do. I'm going to save the phase displacement for last, because the phase displacement can set off arguments in an interesting sort of way. How about the period? Can anybody figure out what the period would be? It is not. Period, anybody? Let's look at my graph that we already graphed, or our graph, I guess I should say. I shouldn't be selfish. On this graph, how could we have figured out a period of 120 if we tried to reverse the process?
The distance between your first point and your second point.
Okay, we go distance from the beginning to end. So from 10 to 130 is a span of 120. Down here from negative 30 up to positive 150, that's a span of 180. We need to work that like backward now. How is the graph on my board, and it is my board, how is that a simpler scenario than the book graphs? Why are the book graphs a little bit more complicated than my board graphs, our board graphs?
They're periodic. Because they're periodic.
Yeah, what do you mean?
They like are continuous.
Yeah, they keep going. We did one cycle. In the book, they're doing a couple cycles. It depends on the question. Like number 14, they did a lot of cycles, yeah. Some of the other ones they did like 2, or 1.5, or 2.5, or they're sort of varied. So what you need to do to figure out the period is figure out, we're trying to measure how far is one cycle's worth of life. Can anybody do that on 9? Figure out how long it takes to get through one cycle.
180.
I could go with 180. Where are you looking to generate the 180?
The negative 70 to the 110.
Okay, that works. Was anybody else's eye drawn anywhere else?
Oh.
Could you do like a mustache, like the upside down one? Like
Dude, I
from
don't
20 to 200?
Yeah, you could go from 20 to 200. Yeah. Okay, what you have to do is find any two positions that are a match. So like 20 is a match for 200 because they're both
The like highest point.
at the high spots. Other people saw negative 70 versus 110 because those are low spots. Find any two matches, and once you have the numbers for the matching spots, like here I have 10 and 130 were matching numbers and highs, figure out the matching points and then do what with the numbers?
Add them together.
Disagree.
Subtract them.
Subtract them. Because we said, somebody said from negative 70 to 110, the period is
180.
180. Or from 20 to 200, it makes
180.
180.
Could you, is a cycle always within like flag hashes?
Not necessarily, because look at 14, they didn't do the hashes the same way.
Okay.
Yeah, so you can't necessarily trust that. You have to trace like from high to high or low to low. Also be suspicious of the middles. Here, if we track from middle to middle, these are actually not partners, because this middle is on its way down, whereas this middle is on its way up. So you can't use two middles if they're going in two different directions. You can still use the middles though. Let's say we wanted to use 25 as a middle that's rising. Your next middle that's rising is
155.
155. Negative 25 up to 155 still could get you to 180. It's just usually easier to do the mountaintops or the valley bottoms. Phase displacement argument.
Great.
Anybody have a thought on a phase displacement? Let's
70.
slot this number while we're thinking, and then I'll look back to 70. 180, where's the period go live?
After cosine.
After the trig word, which might be sine or cosine. Does 180 itself live here?
No.
No. We need a number here so that 360 divided by this number makes the period.
2.
It is 2. We're doing 360 divided by to do the math in this direction. What math do you do to get the other direction in a strange twist? Nope, nope,
Where
nope.
did the 2 come from?
That's what we're trying to figure out.
Oh, okay.
So,
Oh.
we could justify the 2. How have we in the past gone from the equation to the period when we flow in this direction?
Divide.
What division?
360 divided.
360 divided by 2 flows us to 180. What flows us back?
Times 2.
No.
360 divided by 180.
360 divided by again. Division is strange in the sense that if you're doing 360 divided by something to go one way, you do 360 divided by something to go the other way too. It's a little bit like the bearing and degree questions. When we wanted to get from bearing to degrees, what did we do?
Add.
450 minus. What did we do when we went back? 450 minus. So in this world, it's 360 divided by in either direction. Okay, so we're looking to argue about phase displacements. Somebody yelled 70. I say no go on 70 as a choice.
25.
I will say no go on 25 as a choice.
Can I pause back to the other, back for a
Yep.
second? So like for number 1, with the period being 120, so it's the same thing, like 360 divided by 120?
Yeah, 360 divided by 3 got us 120.
Okay,
If we knew the 120, 360 divided by 120
we'll lead you to the 3.
will lead you to the 3.
Okay, thank you.
Yep. Any other phase displacement suggestions?
20.
I could agree with 20, but you'd have to keep talking to me. If I wanted to do a phase displacement of 20, what would have to go here? Minus 20. How is this still an incomplete problem?
We don't have sine or cosine.
We don't have sine or cosine. If we're going to commit to a phase displacement of 20, you are simultaneously going to have to commit to whether that's a sine or a cosine graph. that is a cosine graph. So on your phase displacement part of the list, also tell me what you're committing to. 20 can be a cosine phase displacement. Why? Why?
Because it
Because
started
that's where you
up.
start.
Because cosine starts up at the top. And at 20, the graph is
Higher.
at the top. So some people could argue, I want my phase displacement to be 20, and I'm using cosine. And I would agree with that. What other number could you argue for if you were using cosine that's just as good of a phase displacement?
200.
200 would be just as good. If I demanded to use 110 for my phase displacement, I could save it. It'll be harder, but I can do it. What would I have to do for 110 to be my phase displacement?
Have to use sine.
I would not. I would still be using cosine. How could I use 110 and cosine?
What's the opposite of cosine? Cosecant?
No.
What is it?
It is secant, but no.
Okay.
How could I use 110 as a phase displacement for cosine?
You flip it.
I flip it. How would I have to tweak my equation? So I'd have to go like, I'd put 110, I'd put cosine, I'd put a note to flip it. Where in the equation could I flip it?
You would see the 2.
The two.
Disagree.
The 6.
The 6. When the amplitude in our list is always positive, one of the days of homework they threw some negatives in the amplitude spot, and what that did was flip it upside down. So far we have 3 valid answers. 20 with cosine as we did. 200 with cosine, just add a 0. 110 with cosine, you'd have to do a flip, and that would make this be a minus instead of a plus. We have 3 good answers. What if I wanted to use sine? Where does sine graph start?
150, or like at the
At the axis, but it has to be on its way
Down.
Positive.
up or down.
Oh,
Sine starts on the dotted line axis, and it's on its way up. So what would be a good sine phase displacement?
155.
Okay.
155. So I could say 155, do sine, have this exact same answer but with sine, and go with the minus 155. You don't have to do all these answers. You just have to do 1. But are you all going to pick the same thing?
No.
Probably not. So I can read answers to this in the future like 9 plus 6 trig word. I don't know what you're going to pick. 2 parentheses theta. I don't know what you picked. I can't read you the answer. I can read you a portion of an answer. We'll all have 9 plus or minus 6 trig word 2 parentheses theta doing something. Other than 155, what would be another valid choice?
Negative 25.
Negative 25 would be also a valid choice. Because it's in the dotted thing and it's rising. What if I demanded you pick 65?
You have to flip.
Flip, but use sine or cosine.
Fine.
It would be sine flip if you wanted to use that. And where were we doing the thing to flip?
At the 6.
Negative with the 6. So on the x-axis, which number could be the phase displacement? Well, literally
Any of them.
any of them.
If you put 25, would you put a plus next to theta?
You would, yes. If
Okay.
you were using the negative 70 in your list or your negative 25 in your list as they appear on the picture, in the equation it turns into a plus. Yes, the old minus minus makes plus rule. Yep. Something about 9? Okay, so let's do 10. What I'll ask in the homework that you do is don't use sine every time, don't use cosine every time. Mix it up a little bit. Use a little bit of each, just for experience sake. For 10, spot me any fact.
Vertical displacement 9.
Vertical displacement is not 9.
8.
Other than
It is 8. because we're gonna wanna average the 18 with the -2.